right, so we're at the place in the Springboard book where you should check your understanding. So you've got a few problems to work. So try to work 8, 9, 10, 11, 12, 13. And what I will do, you need to stop the video if you haven't already worked them and work them. And then for the rest of this video, I will share with you the answers to make sure that you're doing them right. And then if you have any questions over any of the, let's say that you got something different and you don't understand what you did wrong, you can either go to a live question and answer session, or you can send me an email. If it's during the time, if you're watching this video during the time that we are in session, so if you're watching it between 9 o'clock and let's say 12 o'clock or 8 o'clock till 12 o'clock, you can go to a live question and answer session. If you are doing it at 2 o'clock in the morning, I can promise you none of us are going to be available. So you'll need to send an email and we'll try to answer it that way. So pause the video and I'm actually going to go I'm going to get off the PDF version of the book and I'm going to go to the online version because it's easier to get to the answers. So stop the video, do your work, and come back and check your answers. All right, I'm assuming that you're ready to check your answers, so I'm going to turn my answers on. So this told me to shift it left 2 and up 1. You should be able to look at that and see what you're doing. You're shifting it left because it says minus, and you're shifting this up because it says plus. And X values go left and right, Y values go up and down. So we took this point right here, go left 2, up 1. And so we ended up at that point right there. And that's where that ended up. And you shift all the other left 2, up 1, left 2, up 1. Okay, here are the ordered pairs. You could take this ordered pair, and what do we do to it? Subtract 2 and add 1. 1 minus 2 is negative 1, and 3 plus 1 is 4. And you can do that for the rest of them. There are those ordered pairs. Is it rigid motion? Yes, it was rigid motion because it maintained the same size. Can you write the transformation rule? Well, how did we shift it? It started off here. This point right here started off up here and it ended up down there. So it looks like I shifted it down. And it looks like, so the X value stayed the same. The Y value shifted down. Is this rigid or non-rigid? This was rigid. How do we know? It didn't change size. All right, for this practice, you should recognize right here, this is not going to be rigid motion. Why? We are multiplying by a half. That's like I said, anytime you multiply, you are changing its size. Now, some of you are saying, I didn't see multiply by a half. I saw divide by 2. Well, divide by 2 is the same thing as multiply by a half. So you take each one of these ordered pairs and the X value stays the same, but the Y value becomes half as big. And then you plot them and this is what it ends up looking like. Is the transformation rigid motion? No, because we made it shorter. It was, 6 units tall, and now it's only 3 units tall. Draw a plus sign in the middle of the image. Describe how it would change. The plus sign would be shorter, just like the image. So again, we're multiplying by a half, so it's non-rigid. All we did was add 2, so we shifted it up 2. That's rigid. Okay, if you have any questions over any of that, please, please, please ask. That was just transformations. I mean, that's just translations. Sorry, translations are one part of transformations. We're going to do reflections next and then finish up with rotations.